Welcome to episode 15 of Agentic Data, podcast about data and AI. I am your host, Joseph Moon, CEO of Oxygen Intelligence. There are a few topics that I wanted to ponder about today. And the first topic that I want to think about is this concept of the shift left data platform. On the heels of Databricks' new funding announcement, I came across this post on LinkedIn that I found to be very illuminating in terms of how Databricks thinks about its data strategy and the strategy that let it have an advantage over Snowflake. I think the battle between Databricks and Snowflake have been a fascinating one to watch. And it's a very interesting fight in a sense because these two companies are so different. One is a founder-led company led by a former researcher, Ali, and Snowflake is a manager CEO-led company that is on its fourth CEO. The first founding CEO being Mike Spicer, who incubated the company, then Bob Muglia, who came from Microsoft, then Frank Slootman, who was previously at ServiceNow, who scaled up Snowflake's operations, took the company public, etc. And now Sridhar Ramaswamy, who spent more than a decade at Google being an executive leading all sorts of data-driven initiatives at Google. And so these two companies are starkly different. One has its roots in open source, so the Spark ecosystem and all the peripheral ecosystem around it. And one is firmly closed source and has this it just works type of mentality. One is slightly harder to grasp, this concept of the data lakehouse, which is in the Databricks case. And on the Snowflake case, the data warehouse is a much easier concept to grasp, but it's having a slightly harder time verticalizing and expanding from there. Snowflake traditionally had more of an ecosystem approach to partnering up with companies and service providers and so forth. Microsoft strategy that likely Bob Muglia put forth, and Databricks traditionally had this we're just going to do everything type of mentality. This is kind of similar to what Palantir did, by the way. And so in some sense, Databricks and Palantir are much closer in similarity in the similarity index compared to, say, Snowflake and Palantir. So in my mind, Databricks and Palantir came up with not the same, but a very similar type of business model independently, coming from very different backgrounds. One from a philosophy king type of background, a mission-driven philosophy first CEO, humanities background CEO with no technical background type of CEO, versus Databricks being led by a PhD researcher CEO and Snowflake being led by a management type CEO. It's very interesting to see all three of these companies doing extremely well and really dominating, but having very different flavor profiles, if you will, in the marketplace. But I digress. Let's get back to the main point. So let me share my screen here. So I came across this post on LinkedIn by Charles Chrétien, who is a co-founder at Prequel. And I think Prequel is a company that allows companies to build a data export feature to data warehouses. I think Charles is an acute observer in the data space. Charles says, "It seems Databricks may have a key structural unfair advantage over Snowflake. This is the best way I could summarize it. They're adding a data warehouse business to a data platform instead of turning data warehouse into a data platform." You may have already seen the stats posted by Ali Ghodsi, Databricks' CEO, as part of their Series L announcement. 55% year-over-year growth versus 29% for Snowflake. $4.8 billion run rate versus $4.6 billion for Snowflake. $1 billion run rate on data warehousing. $1 billion run rate for AI products. 140% NRR versus 125% for Snowflake. Positive free cash flow. Snowflake also with positive free cash flow. First, the metrics are insane. Growing 55% year over year at that scale is close to unheard of, especially while maintaining positive free cash flow. What's especially telling is the revenue breakdown. Only $1 billion of revenue is from data warehousing, only in quotes. That means that 80% of revenue is coming from workloads like Spark jobs, notebooks, and other data engineering and ML workloads. In other words, Databricks is a data platform company which happens to have a data warehouse offering. This data platform is the company's DNA. It started out as a managed Spark provider and grew from there. the company continues to invest in the broader platform, tucking in Tekton, ML feature store, Neon, on-demand Postgres, especially popular with agents, and more. On the other side, we've got Snowflake. The company is a data warehouse at heart and has been since its launch. It's expanding into other product lines, e.g. Cortex, Snowpark, the Streamlit acquisition, etc. But it's fair to assume that the bulk of its revenue still comes from data warehousing. Its metrics are impressive given scale, but Databricks is pulling ahead in terms of growth. And this is the core tension at the center of this race. Databricks is a data platform dabbling in data warehousing. Snowflake is a data warehouse vying to become a broader data platform. Absent dynamics like talent, funding, etc., I would wager it's easier to pull off the former, parentheses, grow a data warehouse line of revenue within a data platform, than the latter, turn a data warehouse into a broader data platform. The most recent metrics seem to confirm this. Databricks grew its warehousing revenue from $0 to $1 billion in 4 years. Meanwhile, it's not clear from the financial statements that Snowflake has managed to grow its non-data warehouse data platform business to anything close to that scale. This is the bull case for Databricks. They can keep on expanding their warehouse business while also continuing to grow aggressively in other lines of businesses, including AI/ML, data pipelines, and more. In fact, the recent funding announcement mentions heavy investment in those. As they do, it'll be increasingly difficult for Snowflake to go toe-to-toe with them. That said, the Snowflake team and tech are stellar as well, and if anyone could give Databricks a run for their money, it's them. It's a good time to be watching from the sidelines. Very surprisingly, Ali Ghodsi, the CEO of Databricks, replied to this post on LinkedIn and said, "Charles, I think Snowflake is a great and impressive company, which has executed exemplary. But yes, I do think it's easier for Databricks because it's a shift left strategy. So it's easier to pull off. Quote, you're already doing ETL into DW with us. You might as well try our DW here. Same with open data formats. 100% of the data, structured/unstructured, was on the lake from day one. So no big migration was ever needed. Operating directly on all the lake data made it easy to do AI from day one. Databricks' first 2015 Summit demo was doing AI. And yes, staying private also helped with all the future-looking investments. This is fascinating. I read Bob Muglia's book, Datapreneurs, to get his perspective on the Snowflake days. And I think I also read all of Frank Slootman's books to try to understand what was in his head during the pre-Snowflake days to the Snowflake days. And I think what I need to say is that it looks like Ali and others at Databricks has a much wider imagination and is highly, highly adaptive to change and has a very good read on where AI is going. I read Databricks' first deck that they put out to the market, and its focus was really on enabling large-scale machine learning workflows by being able to engineer the data that power those AI and ML workloads. So statistical machine learning, really, not deep learning. And because it started with that fact in mind, it did take, say, 10 years for AI to really become a real thing, unlike statistical machine learning. But it was really well positioned to actually just capture all that value 10 years into the company. And because Snowflake had a much more narrower thesis on let's just make data warehousing on the cloud. And, Mike Spicer recruited folks from Oracle who have been there, done that to build a new type of data warehouse on the cloud. Because of that, I think this narrower positioning really helped out in the early days. And now the company's having a hard time due to its DNA in really going from data to AI. So one was really an AI company in disguise of a data company just because AI hadn't taken off yet, versus one was purely a data analytics company now trying to expand into AI at scale. And from that perspective, from a company DNA perspective, it does seem like Databricks has an advantage from the top down here. And this shift left data platform idea is quite an interesting and profound one. And it likely was a huge disadvantage from Databricks' perspective in selling this data lake plus this Spark cluster to kind of almost hack together this data lakehouse. This doesn't feel like a super cohesive product, this lakehouse concept. But because Databricks laid the foundation with the lake, and now this lake is able to power a lake house and a lake base, which is sort of the lake version of say, an OLTP Postgres database, say with the acquisition of Neon. Then Databricks is really able to capture the structural advantage that it has, which was a structural disadvantage before, and now really turn it around and really dominate here. And AI really runs on data. It's really tried to say, but AI runs on both structured and unstructured data. And it's extremely clear that Databricks has an extremely good position in being the center of gravity for all the data files, even structured data files that it uses to do data warehousing, and unstructured files like videos and documents and other media files, and consolidate all of them together and have a platform wherein one could run data workloads as well as AI workloads. So this is an extremely powerful concept and a powerful platform that is really moving quickly, just because I think a researcher and founder-led company, these could be amazing companies. These could be amazing technology businesses. And I'm glad to see that the founder reign, the founder power is back, so that these research-driven folks could really accelerate technological progress. And we've seen in the previous episode that I talked about IBM's new CEO and how he is really driving forward a culture of innovation and research, it seems. And in an age where research and customer service are the two remaining moats left in technology, especially in enterprise software, this change makes a lot of sense. And the change from Slootman to Sridhar at Snowflake as CEO, Sridhar having a PhD background and having more of a research and technology development background from Google, this makes a lot of sense. So in sum, I think what is really important in an enduring and growing business is that you create a structural advantage that might not look like an advantage in the beginning, may look like a disadvantage, and then you turn that into your key advantage. Even for a company like Palantir, which is completely dominating right now, was just not well received. Nobody really understood what Palantir was doing back then. I don't think people understand what Palantir is doing now. I think people think that Palantir is still building software for the CIA to track people down, but that's really a small portion of its business. Palantir really had to build a full-on data and AI stack from scratch to really propel its business. And when that platform was developed, like a few years ago, 5+ years ago, then it was able to really truly accelerate. And before that, before Foundry, before all the platforms, before AIP, before Foundry, I think Palantir looked like a very, very different type of business, more like a services business. It does resemble a type of service business right now, but it's really pivoting into a product-led, a platform-led business. But before it looked almost purely like a service business. And the services roots really give Palantir an unfair advantage that Databricks just doesn't have, which is Palantir is able to go after companies in which the company itself does not have the human resources to actually adopt a self-service data platform like Databricks or even Snowflake and run things at scale. So Palantir could deploy its forward deployed engineers and deployment strategists to really, in say like an Accenture or Deloitte or McKinsey style of consulting, not management consulting, but sort of this deployment consulting, roll things out in tandem with its customers, which is insanely hard to build this type of business model, insanely hard. Also hard to get funded for this type of company, because traditionally people don't want to fund professional services companies. But when pulled off, it's just these companies have an incredible moat in terms of service deployment and service rollouts to Fortune 500 like companies. There's a reason why Accenture, which is likely the largest player in tech consulting in terms of market cap and revenue, there's a reason why they're worth $150 billion. Services are heavily needed by enterprises, and oftentimes these service providers also get to dictate what products these Fortune 500 companies end up buying. Accenture is like a TSMC where you're just a layer that provides a service, but you're not competing with your customers. Your customers are, say, yes, the Fortune 500 company is a customer, but then on the flip side, you have companies like Databricks that wants to distribute its products through Accenture. Accenture is not really competing with Databricks. Databricks is not competing with Accenture, so they have this symbiotic relationship. But Palantir is likely saying, no, we don't go through Accenture. we're just going to do everything ourselves. So this verticalization of this service layer and then the platform layer is quite a strong one that is extremely hard to replicate. In some scenarios in which, if this scenario was a scenario in which a company really needed a lot of services, then it's likely that Palantir will be able to actually deliver a lot more at a similar price point to Databricks compared to just getting Databricks alone. So it's interesting to look at this shift left dynamic from a platform perspective in looking at Databricks and Snowflake. But there is this other verticalization strategy that is going on where Palantir is a heavily verticalized solutions provider. So Foundry platform, AIP platform, plus the services layer, all bundled in, no Accenture needed. Just deploy everything just in one go versus, say, like the Databricks plus Accenture stack that folks purchase. And that's a different type of strategy here. And so the difference between, say, Databricks plus Accenture and Palantir, this is sort of, it's not a shift left on the platform perspective. It's more like a shift right on the services perspective on the Palantir side, where Palantir is definitely able to structurally do things that Databricks can't do. And the key thing that Palantir could do is go after more legacy industries and just dictate all of the product spending back onto itself rather than give that away. So give that away to other product providers. So it could really capture all of that value by itself, which allows it to still trade in a high growth technology oriented fashion rather than trading at 1x revenue like Accenture. Okay, so those were my thoughts on shift left data platform, Databricks, Snowflake, and Palantir. Okay, let's move on to the next topic. I wanted to talk to you about this concept of the single model of truth. In the early 2000s, and the 2010s, I think that the concept of single source of truth emerged, and folks started to understand the value of having a single source of truth on the cloud. Previously, starting in the 1970s and 80s and 90s, folks ran their businesses on desktop software. So all your data was likely on your desktop, or likely you were running a single server with a database with all the data, but that database really didn't connect to other databases. It didn't really talk to each other and so forth. But that was still called your single source of truth. And then really with the invention and the advent of internet-based businesses, so public internet-based cloud products, and Salesforce being like one of the canonical ones, then one could really have a single source of truth on the cloud. So no more database wrangling, no more syncing issues, everything just on the cloud, available to everybody, every user at all time. And that concept, I think, organized itself around this phrase, single source of truth. And that's what these canonical enterprise platforms are. The CRM, the HRIS, so ITSM and ERP, all these canonical platforms to manage people, money, manage sales and customer relationships. These canonical platforms are thought to be the single source of truth, the system of record for all this data for the entire company. And that is the single most useful thing about these platforms. Yes, being able to run intelligent workloads on them and being able to coordinate between teams, etc. Okay, these are a byproduct of the fact that these platforms are considered the truth for the canonical data of a company. And I think a second layer to that will be forming in this decade, in the 2010s. I call this concept the single model of truth. And this single model of truth, a lot of different companies have been trying to approach things from a knowledge graph perspective, from a semantic layer perspective in the sense of BI, the ontology perspective from Palantir. A lot of folks have been trying to get to this concept. But I think the difference here is that we now have AI, and AI workloads are going to necessitate this concept of single model of truth, which is a single contextual plane that allows data platforms and AI platforms and agents to run its workloads. You need a single pane to have a model of your business and a model of your people and a model of your preferences to be able to precisely execute all your tasks. And I think this is why the single model of truth is really important. And a single model of truth should connect into all your single sources of truth and then create this meta layer on top of, say, the CRM, the ERP, the HRIS and so forth, a layer above that, and then serve as this metadata layer, not the metadata catalog type of situation, but a new type of metadata layer that connects across the SSOTs and then creates this layer for the AI agents and AI applications to consume content and context and then operate in a pristine, precise, and accurate way. And I think there's going to be a grand unification here on the single model of truth, on this single model of truth layer, wherein the semantic layer obviously is a limited version of this in the sense of the semantic layer only contains information about metrics and dimensions. So really just how do I get the metrics and how do I cut the metrics into dimensions and how do I display them into dashboards? That feels incredibly limited. That's really like saying my business is just a bunch of metrics. That obviously is a reductive view on the situation. And for knowledge graph based companies pre-AI, yes, you were running workloads on this knowledge graph, but for what purpose? I don't know. Yes, like for the purpose of trying to understand your data better, but without the application side, namely the AI application side, motivating the behavior, infrastructure is usually useless. You need the application side to motivate the infrastructure side. Otherwise, you're just building infrastructure for absolutely nothing. And so those legacy or incumbent players on the knowledge graph space may not be able to stand a chance against a newer player. And it's unclear who's going to take over the space. But I think whatever this you want to call this concept, and I want to call this the single model of truth. Maybe this is the enterprise context layer. People have different terms for this, but whoever owns this is going to have a very strong chokehold in the enterprise landscape. Now, for the final point, I want to talk to you guys about research engineering as a separate discipline. First of all, I have this view that everything is becoming and everything should become an engineering discipline. Even though I started out my career as a research scientist, reading papers and actually taking theoretical machine learning papers and turning them into practical machine learning algorithms. That's what I started my career doing, in being this research scientist. And there is great value in being that person in translating research into practical matters. And then later I called myself a data scientist because I really got into modeling data and then really understanding data for the purpose of deploying machine learning algorithms, because wrangling data is maybe 80 to 90% of the value of what you're going to get out at the end of the day. But still, these folks were called data scientists at the end of the day. And while I liked the term back then, and maybe in the 2010s, a lot of folks said that being a data scientist might be the sexiest job of this decade or something like that. I think we need to shift the nomenclature a little bit. I think standardizing around engineering practices is likely the best option here. I think engineering is really a practice of building things, and your focus is really on building things, not understanding things, not translating things, not coming up with new things, really per se, although you do come up with new things on the way, but really focus on building things in an effective way. And I think there's great power to framing everything in terms of building, and as opposed to just like thinking and discovering. These are less highly desirable economic activities. It's very similar to, say, if you analogize engineering from a perspective of making drugs, all of the discovery efforts is done in an extremely high-risk way in drug development. High-risk way, a lot of them, discovery work is done in labs funded by the federal government through, like, say, NIH and NSF grants and so forth. This is sort of considered maybe like at risk or throwaway money that doesn't scale very well. You don't want to fund scientific research because the money doesn't scale that well. And it's not clear that throwing more money at a problem will get you more results. So extremely difficult place to invest in. But what is a much better place to invest in is further down the line, where if the science risk has been de-risked on, say, targeting a novel mechanism and coming up with a new family of drugs to target this pathway inside your body, then finally you could actually create an economic mechanism in which you fund the building of the delivery of this scientific promise. And I think that's the difference between science and engineering. And so data has really gone from a scientific discipline into an engineering discipline, wherein one should just think about just building infrastructure, building artifacts, building applications for the most part, building scalable applications, scalable infrastructure so that a lot of folks could self-service their own insights instead of having to go through a human. And from that perspective, I think we saw a transition from data scientists to data engineers, really. And I think there are front-end data engineers and then front-end and then back-end data engineers. Front-end data engineers are sort of the BI engineers that are building Looker dashboards, Tableau dashboards, Power BI dashboards. And then the back-end data engineers who model out the semantic layer, they set up the data warehousing capabilities, they set up data pipelining. And I think the general trend is everything is just becoming more and more technical, and being technical is more rewarded, and it's becoming easier to be technical. Folks should be using code to define these data applications rather than always using these point and click solutions. So I think that's like the next generation of front end data engineering. Okay, but just this move from data scientists to data engineers. So I think we see this trend. And I think right now we are seeing this trend of, say, at OpenAI and Anthropic and Meta, research scientists are, getting enormous pay packages to work as scientists, doing science, doing discovery work in pre-training and post-training and things like that. But if the future rhymes with history, there's only a finite amount of time, let's say like 5 years, in which being a pure researcher is really going to pay off. I think we have a few more years left on the clock on being a pure researcher having utility. I think we're going to really transition, just like how data scientists transitioned into data engineers. We're going to see research scientists transition into research engineers, in which a lot of the work being done is research, but building upon that research rather than doing the de novo research themselves. Because this party is going to end at some point where the pure sort of scientific research on language models and diffusion models, the marginal utility of an additional dollar is going to be very, very small compared to the marginal utility of deploying this dollar into research engineering, which is like the translational layer. So we're likely going to see this shift. And for that reason, I think if we were to front run this type of shift, then we should think about research engineering as the core discipline and not science as the core discipline of AI research and engineering. I should say research engineering and customer service are the two enduring modes in this brave new world. Not pure research, not scientific research, research engineering, which is really about consuming the bleeding edge research and translating that into practical engineering assets and artifacts that could be used to propel other engineering disciplines. So there you have it, folks. These are some thoughts for this week. We'll see you next time on Agentic Data, podcast about data and AI.